Good afternoon, students. Now we will start with exercise 7.3. Here is the first question. The figure is given to you in this triangle ABC and triangle DBC. You can see here ABC and DBC are the two triangles on the same base BC, and vertices A and D are on the same side, are to the same side of this BC given to you. If AD is extended to intersect BC at P, then you need to prove first part, triangle ABD is congruent to triangle ACD. So now let us see, and feel free to apply all the results whatever you have studied before this exercise, all criterions with SAS, SSS, ASA, AAS and RHS, whatever is possible there accordingly. So just see this triangle, ABD is this triangle, and then ACD is this triangle, in which it is given that ABC and ABC isosceles triangles. So here I am given with AB is equal to AC. This is given, and this is also given BD is equal to CD. Another triangle BDC is also given, that is isosceles. So in these two triangles ADB and ADC, I am saying AB is equal to AC, BD is equal to DC, and then AD is equal to AD. So all three sides I have proved equal. So by SSS these two triangles will be congruent to each other. So if these two triangles are congruent, you remember that I am writing here, this implies your angle 1 is equal to angle 2 by CPCT, somewhere by CPCT. In next part somewhere, if you need, you can use the same. Then come to this triangle ABP and ACP. Now here AP is equal to AP, that is common in both, you can see, and then this is given AB is equal to AC, AB is equal to AC, this is given to you, and I have proved angle 1 is equal to angle 2 already from 1. So this is your SAS. This side is equal to this side, this is the common side, and this angle is equal to this angle. So these two triangles are congruent by SAS. Therefore I can say angle 3 is equal to angle 4, again by CPCT. Once you have proved these two triangles congruent, then 3 will be equal to 4. As well ABP, sorry, not 3 and 4, that will be 5 and 6. ABP, here it is 5, APC, here it is 6. So 5 will be equal to 6. Now in third part you need to prove angle 1 is equal to angle 2. That I proved here, 1 is equal to 2 in first part already. 3 is equal to 4 if you want. So here you can pick these two triangles, that is your DPD as well your DPC. So number of options are available with you. So this is equal to this is the common side, and BP is equal to PC already. Once you have proved these two triangles congruent, so BP is also equal to PC. Again, that is the reason CPCT. So in these two triangles, now you see, that is your DPB and DPC. DP is equal to DP1, PB is equal to PC2, and angle 5 is equal to angle 6. Already I have proved. So these two triangles are congruent to each other by SAS. I repeat, in triangle DPB and triangle DPC, DP is equal to DP1, then PB is equal to PC. I have proved already here, you see there, and now angle 5 is equal to angle 6 also I have proved. So 5 is also equal to 6. So then by SAS, these two triangles will be congruent to each other. So by CPCTC, you can conclude that 3 is also equal to 4. So that is the proof for your third part. Then in fourth, BP is equal to PC. Already I have proved. 5 is equal to 6 I have proved, but you need to prove it is equal to 90 degree. So 5 plus 6 you can see is equal to 180 degree. Because because these are forming a linear pair there. If this is x, this is x. Why? Because 5 is equal to 6. So each can be of x degree. So this implies each angle will be of 90 degrees. So if x is 90 means 5 is also 90 and 6 is also 90. So in other language you can say, in other words, AP is the perpendicular bisector of BC. Once you have proved 5 is 90 as well, 6 is 90. So I don't think any difficulty should be there in any of the parts after doing so many applications belonging to all these criterions of your congruency. So you can proceed all the 4 parts. Keep a watch upon your performance, but please keep on writing the reasons for the same besides whatever you are going to prove. So that was all about your question number 1. Then comes to question number 2 of your this exercises. Question number 2 of your exercise 7.3 is, AD is an altitude of an isosceles triangle ABC. So this is the triangle ABC where AD is the altitude given to you and AB is equal to AC. So given AB is equal to AC and AB is perpendicular to BC. What you need to prove is AD bisects BC. To prove AD bisects BC means BD is equal to BC. First part you need to prove, and second part AD bisects A, also you need to prove angle 1 is equal to angle 2. So I think if you just can prove this triangle ADB and triangle ADC similar to each other, congruent to each other, then by CPCTC both of the parts will be proved. So look at this. In triangle ADB and triangle ADC, in triangle ADB and triangle ADC, here AB is equal to AC 1, then your AD is equal to AD 2, and your angle ADB will be equal to angle ADC. ADB is equal to your angle ADC. So this is given side. AD is equal to AD is your height, and your angle ADB, that is of 90 degree. So this is the hypotenuse AB and AC. This is the hypotenuse, this is the side, and this is 90 degree. So RHS is the congruency to prove these two triangles ADB and ADC congruent. So these two triangles will be congruent by RHS. Hence your BD is equal to DC by CPCT and angle 1 is also equal to angle 2. So prove these two triangles ADB and ADC congruent to each other. I have given you the idea. RHS will be there. This is the right angle, this is the hypotenuse, and this is the side, which I have proved are equal to each other. So two triangles will be congruent by RHS. So remaining parts, that is BD will be equal to DC and 1 will be equal to 2, which you need to prove in question number 2. Then question number 3 is, there are two triangles given to you. One is your ABC and another is your PQR. This is your ABC and this PQR. In ABC, AM is the median given, and in PQR, PN is the median given. Then AB, BC and median AM. So what is given? AB, side BC and median AM of one triangle, that is of ABC, are equal to, respectively equal to PQ, then it is QR, and then it is PN of the another triangle. So this is given in both the triangles to you, and you need to prove triangle ABM. Triangle ABM is congruent to triangle PQN. First part is this, and finally your triangle, also in second part you have to prove that whole of this triangle ABC will be congruent to your triangle PQR. Again, I don't think any difficulty you people will be finding to get the proof of these two parts. So I think enough information is available with us. AB is equal to PQ when we are speaking about the first part. AB is equal to PQ1 and your AN is equal to PN also. Now you look at this. We are given that BC is equal to QR. So on that behalf I will write BM is equal to Q1. Why? Because BC is equal to QR. As AM and PN are the medians, so your BC by 2, that is half of BC, will be equal to half of QR, because these M and N are the midpoints. As you know the property of median that bisects the base, so half of BC I can take as the BM and half of QR I can take as the QN. So BM will also be equal to QN. So triangle ABM will be congruent to triangle PQN by these three sides. You can, this is equal to this is equal to this, already given to you. As BC is given equal to QR, so half of BC will also be equal to half of QR. So QM BM will be equal to QN. By SSS you can say the triangles are congruent. So if these triangles you have proved congruent, so don't you think that I can take this implies angle B will be equal to angle Q. What is B? ABC. What is Q? PQR. And now in triangle, second part ABC, AB is equal to PQ given, BC is equal to QR given, AB is equal to PQ given, BC is equal to QR given, and angle ABC is equal to angle PQR, that I have proved here. So triangle ABC will also be equal to triangle PQR. Which criterion? That will be your SAS. So comfortably you can get the proof of your second part also. The congruency we are using here in second part is your SAS. Definitely it is connected to your first part. So please check the same. Then question number 4. BE and CF are two equal altitudes of triangle ABC. So draw triangle ABC. From B one altitude is drawn BE. From C the another altitude is drawn, that is your CF. So BE and CF are the altitudes given to you, and this is given are two equal altitudes. So BE is given equal to CF. Write the information. BE is equal to CF, and using RHS, this is the condition. Prove that triangle ABC is isosceles. Prove, can I say AB is equal to AC? Means somewhere I'm talking about this angle and this angle. If I can prove are equal, then comfortably by the converse of the property of your isosceles triangle, I will be reaching here that AB is equal to AC. Once the angles are equal, base angles are equal, then the sides opposite to those angles are also equal. So let us pick these triangles first. One you can see here is right angle, that is here this one. Second, if you see somewhere is this one. So here it is, EBC. Now again, I don't think any difficulty in finding to get these two triangles proved congruent. Why? Because here when you are going in your proof, you see in these two triangles, angle F is equal to angle E, 90 degree each. Altitudes are given equal, that is your CF is the one altitude here, and BE is the another altitude here. So mention that also. CF is equal to BE also is given, and then here BC is equal to BC, that you can see also common. So in these two triangles, I'm talking about these two figures, you see these three things are equal, so it means the triangles are congruent by RHS. RHS why? because opposite to vertex hypotenuse is always there. So BC is BC, that is the hypotenuse. CF and BE, this is of 90 degree and this is the side altitude 90, angle SH. The right angle R, side S and hypotenuse H. So RHS is the congruency you can apply in these two triangles. So then you look for this angle FBC. So therefore can I say from these angle B will be equal to angle C. Why? CPCT. Is it or not? This angle B will be equal to this angle C. But let us read it here. If you are reading this angle FBC of this triangle, can't I say that is equal to ABC? So this is your angle ABC. And here if you are reading ECB, so ECB can also be read as ACB. Why? Because AE and C all are collinear. So finally when you are writing B is equal to C on behalf of these two triangles, so you can read it as ABC is equal to ACB. So by the converse of your isosceles, you'll be able to write finally AB is equal to AC. That is the solution for your question number 4. And the last question, that is number 5 of your this exercise, is ABC is an isosceles triangle with AB is equal to AC. So this is the question number 5 here. ABC is an isosceles triangle with AB is equal to AC, that is given to you. Draw AP perpendicular BC. This is also given, AP perpendicular BC. So whatever is given, please write that AB is equal to AC and AP is perpendicular to BC. What you need to prove is show that angle B is equal to angle C. So to prove angle B is equal to angle C, we have done this question already. You see, I don't think any difficulty should be there to write the triangle APB is congruent to triangle APC by RHS. Why? AP is equal to AP in triangle here APB and triangle APC. What is there? AP is equal to AP. Common, angle APB is equal to your angle APC, right angle, and this is given to you. AB is equal to AC. AB is equal to AC is also given. So now this is the right angle given, this is the hypotenuse and this is the side. So by RHS, both the triangles are congruent. Again, these two triangles, three things I have proved are equal. So one, your AB is the hypotenuse is equal to AC. So this stands for height. APB and APC both will be the right angles. This stands for R. And AP is equal to AP is the common side. So this stands for S. So these two triangles are congruent by RHS. So therefore your this angle, that is B of this triangle, will be equal to angle C of this triangle. Hence if the sides of any triangle are given equal in any triangle, then the angles opposite to those will also be always equal. Hence proved. So that's all about your solution of exercise 7.3. Tomorrow we will start with the new concept of inequalities in triangle and then the application part. So please go through the solution of all these 5 questions. Take your time. Thank you.